All right. Good morning again, everybody. Let's get started. So we need to talk about something that happened while we were online mostly, codingbat.com. So I'm not sure exactly what's going on with codingbat.com. This has been a very reliable tool. We've been using it like literally for probably over 5 years now without like a problem. This semester, it's our luck. They have a problem. Actually, I'm not 100% sure it's server-side issue or it's an issue with some of you. So just a quick show of hand. How many of you have problems right now with CodingBat? Okay, so there's about like, it's not representative here, but there's about like, I would say, a third to half of the students who do not seem to get their grades because when they complete the exercise, it doesn't record them on the server side. So refer to the Piazza post, okay? We have a plan B. I'm going to ask you to still use CodingBat because it's working, but since it's not saving to the server, right? I need you to keep a cut and paste for now of whatever you enter in CodingBat. So I have just like a text file, a plain text file on the side, and save like that your stuff. We are going to collect those text files if we cannot solve the problem one way or the other. But I really invite you to actually come and see the TAs, okay? So I do apologize for the little mess up. It's a big mess up actually, but we still lack data to troubleshoot it correctly. So that's why I'm inviting you to come see the TA so that, for instance, we can take a look at your JavaScript console. Another thing that I'm going to do is I'm going to post real soon a Piazza poll, okay? Just to get actually the name, the definitive list of everybody who is still having issues with JavaBat. So that is going to allow me to come to the author of JavaBat and contact him and say, okay, these are the accounts that I want you to look into, okay? But again, before we do that, if you have time to drop by office hours so that we can remote into your desktop so that we can check actually what's going on with the JavaScript console, basic stuff, right? Making sure that there's not a fetch request that is not actually returning or something like that, that would help a lot. Either way, we're going to make sure it doesn't affect your grade negatively, okay? So be reassured at least for that. So jumping back into the content, so we are on module 6. We're on module 6, useful methods. We covered like mostly math methods, stuff like that last time. We are going to conclude most likely module 6 during this session. We don't have too much to go over, but we have actually an interesting topic to go over. We are going to study strings. So string is a data type in Java, but it's a different data type compared to what we have been playing with until now. So that's what makes it interesting. So we can declare variable of type string. For example, string message. So you put the keyword, actually it's not a keyword, sorry. You put the name of the class string, uppercase S, wherever you would put the name of a data type like int, etc. But you can tell there is a difference already by the way those data types are spelled. Int, long, float, double, all lowercase, right? These are called primitive Java data types. This is like the minimal set of data types that comes with the Java language. So there are like about 7 of them, right? Their name never change, and they are limited. That's it. There's just 7 of them. What we're talking about here with string, we're talking about a new kind of data type. We're going to refer to all of those new kind of data types as reference data types, okay? And the one that we have been using and spelling all lowercase until now, primitive Java data types. So what's the difference? Well, I can still declare variable. I can still declare parameters for my methods. I can say that a method is going to return a string. So I can use those new data types everywhere I was using the old data types. When it comes to initializing them, okay, when it comes to initializing them, I can use literal values that we have been using since day one, okay? System.add.println hello world. I told you hello world between double quote is actually a string literal. So it's a literal value of data type string. Well, now we can declare also variable of data type string. So all of those are things that we have been doing with the other data type. So what makes a reference data type, like string, different from a primitive data type like int, float, long, double, and so on and so forth? Well, that's a topic that we are going to work on a little bit now and a lot in COP2513. Because guess what? The primitive data types, okay, you remember them? They're just like numerical, char, Boolean, stuff like that, right? The reference data type are going to be any class that we write in Java. So while the list of primitive data type is short, 7 or so, the list of reference data types in Java is infinite. Every time someone somewhere writes a class and you get their code, you just added a class to your code, to your project. You added actually a data type to your project. I'm simplifying a little bit here, but the equivalence class data type is okay for the purpose of our code, okay? So we are going to encounter a lot of those reference data type, and we are going to encounter them very often as soon as we start writing our own classes. So we did technically write our own class since day one because Java forces us to, right? We have to start with public class, blah, blah, blah. But it's really in COP2513 that we learn how to design and implement classes as we learn object-oriented programming techniques. So for now, we just need to get the ID, the general ID of those new types of new kind of data types, I should say. So what happens when you have a declaration like int value equal 42? So that's a primitive Java data type, okay? And what you get is a variable in memory, which is some space in memory is reserved for storing a value of data type int, and you shove the value 42 inside that that space in memory, that location in memory. Well, I'm pretty sure this is what 99.99999% of all of you were visualizing when they thought about a variable, okay? And that's fine. That's like the same way in Python, kinda. And it's very basic, right? That's why we start with primitive data types. They are very intuitive. The variable is a bucket that contains the data, okay? And what happens when you declare string name equals something? Well, that's why we call them reference data type. What happens is we still get a variable in memory, right? So here's my variable value, here's my variable name. But what goes inside of name is not the text, is not the something text that we have in this example. What goes inside the variable name is pretty much the equivalent of a memory address. It's not exactly a memory address, it's called a reference, okay? When you guys take COP3515 and you deal with C programming, you are going to deal with pointers. Pointers are variables that contain a memory address. So pointers and reference variables, they're kind of like, going hand in hand, right? They're very similar. Fortunately for us, reference variables are a lot easier to use than pointers. So we start with the stuff that's actually a little safer to use, reference variables, and then progressively you'll transition to the C language and you'll use pointers, okay? And with them will come a lot more power, but a lot more responsibilities as well. So what's the deal with that reference value that we store in that so-called reference variable name? Well, it's going to be the address where I can find the actual object, okay? So it allows me to say that the variable name contains some information that allows me to find the text of the string that I want to store. So I just mentioned object. This is an object. This is not an object. This is a variable, a traditional primitive variable that contains a value. This is a traditional variable that contains a value, a reference. But this is another animal completely. When we do scanner s equal new scanner, every time we have been using that new keyword, which is not a lot, I mean, mostly with scanner, right? But every time you use that new keyword, you are asking a class scanner to create an object of that class. That's what we're talking about here. So here, I don't have the new keyword. Oh yeah, that's going to be another story mostly for COP2513, but still, string is the name of a class. Every time you manipulate something of data type string, it's going to be an object of the class string. So object, they kind of live in their own separate area of memory. And all we can do with variables, we can reference them. So technically, a variable doesn't contain an object, ever. The variable's name doesn't contain the text something. contains a reference where to find the object of data type string that contains the text something. So it seems like a lot of, contortions for no real purpose. Why are we making our life so complicated? Why can't I put like something in here and be done with it? So this is one of those things where I'm going to ask you to be a little patient, because there are a lot of things that hinge on this, okay? And a lot of languages are still using that model. So while some languages tend to say, oh yeah, the variable contains the object, blah, 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 Java is an example of a language that clearly separates variables from objects. So it's good to be exposed to that kind of stuff. And if one day you work with a language that say, forget about this, the object is in the variable just like the value 42, or even better, there's no such thing as primitive data type. For example, Ruby, I think, is one of those languages that says, I'm not going to make a difference between, primitive data type like int, float, double, and actually object. I'm going to make the int, float, double actual objects as well, so that everything is an object. Well, that's fine, but every language is different. So this is one of the things, today you learn one of the details about programming language that you want to be on the lookout for whenever you learn a new programming language, okay? So whenever you learn a new programming language, now your reflex will be, okay, what data types do I have? Are they different kind of data types? Are they primitive data types that work like Java primitive data type? Are they reference data type that work like Java reference data type? Is everything primitive? That would be the C language. Is everything reference? That would be the Ruby language. So you see, as you get exposed to those things, I go a little bit deeper, just a little bit under the hood, just to give you enough food for thought so that you know that, hey, I'm learning something here today, but when I go out there and learn a new language, it might be different. So this is what I need to pay attention to, okay? So this is really familiar in a way, because we've done that. Like when we declare the variable scanner s equal new scanner system.in, we declared a reference variable named s. The fact that it has a data type scanner meant that this reference variable was meant to hold a reference value pointing to an object of class scanner. That's actually the pedantic way to read this whole thing, okay? I declare the reference variable s meant to hold a reference to an object of class scanner. And from now on, this is actually the formulation I'm going to use whenever we talk about those reference variable. And by the end of COP2513, you see exactly everything that it entails. Okay, we are just scratching the surface here. So, string is the name of a predefined JDK class. So we've seen some of them. We've seen system. I think that's all of them actually. System, like system.out.println. Math, that we used to call methods like math.square-root, math.power. I mean, refer to the previous lecture, right? There's a bunch of them. Character, that's a class that was introduced before Spring Break. Again, we used to call it method. And then scanner, which we used to create objects. And then we call the method through the reference variable that refer to those objects. Well, string is going to be like that. String is going to allow us to create reference variable of type string. Then we're going to create object that contains a text. And then we're going to make the reference variable point to that object of class string. And we're going to call method on that object. So there's a bunch of stuff we can do on string object. We're going to go over those things during this session, right? But the way that it works is really similar to the way the class scanner worked. Let's take a look at this example. The question here is, does it matter? And unfortunately, to show you that actually the difference between primitive Java data types and reference data types matters, to show you that actually there is a big difference that we can already experience here, I have to jump a little bit ahead. I have to introduce the notation of arrays. Now, everybody has, actually, I don't know if everybody, no, not everybody has taken Python before. So how many of you have never played with arrays? Okay, a few, that's fine. So I'm going to explain as I go, but please know that this is going to be something we cover completely, thoroughly in a few modules. Okay, but right now I'm just going to give you the idea. So this piece of code here, let's build it actually together so that I can start with a simpler example, okay? So in this piece of code, I want a method. I'm going to say public static void. Don't say it. There we go. Thank you. All right, so I'm going to start with a public static void method, method one, okay? Text no parameter, and method one. I forced myself to comment because you guys are looking, otherwise I would not. Inside the main, I'm going to say int data, okay, equal 42. And then what I'm going to call is I'm going to call method one, and then system.out.println after, and I'm going to display the value of data, okay? And then here, I'm going to go here and say before, and I'm going to display the value of data. So inside the method, I'm going to say data equal 99, okay? If I try to compile this, so I'm going to go very far, okay? Variable data cannot find symbol. Yeah, we've seen that at the beginning. As soon as I introduced methods to you, I told you each method is kind of an isolated program, right? All the variable they declare, they are only inside that method. So technically, there is no way for me to modify inside the method one, to modify a variable like data that is defined in the main. Well, what about parameters? What about if I say, you know, method one is going to take a parameter. I'm going to call that parameter P, and then I'm going to say P equal 99. And when I call the method, I'm going to pass data, okay? So if I compile this, well, good news, it compiles. Now if I run it, before and after 42. Yes, same story. Every method is its own isolated kind of memory space where all the variables for that method live. So what do we have here? We have a method main. Inside the method main, there is a variable data. It's set to 42, okay? And then I call method one. What happens when you put the name of a variable here or an expression or like anything, right? You evaluate it first before to call the method. So I evaluate data. How do I evaluate a variable? I look inside of it. I find 42. So the value 42 is what I pass to method one. Method one accepts value 42, stores it in its own local, you know, a variable, P, the parameter, and then it does whatever it wants with P, like change its value, whatever. And when I reach the end of the method, that's it. P doesn't have a reason to exist anymore. I am done executing the code for the method. So I transferred the value 42 from data and I copied it inside of P. I modified whatever was inside of P, and then I got rid of P, returned here, and when I try to display data from main, it has not changed. That's the behavior with any primitive data type. That's what we have been looking at until now, okay? So now what I would like to do is I would like to show you what happens with a reference data type. Unfortunately, string is not going to change things in this example. So string is maybe a bad reference data type to start off with, to encounter first, okay? Because it's not representative of what happens. So I need to use a different reference data type. So in Java, all modern programming language, okay, we have the concept of array. So I can say I'm using the square brackets here, open and close square bracket. That's a symbol that tells me I don't want data to be one int variable. I want data to be a series of int variable stored one after the other in memory, a vector, okay? So that's what an array is. So if I say here, data equal 42, that would not make sense because there are multiple values in an array. So if I say, for example, my array is going to contain the value 1, 2, and 3, that's the syntax to initialize an array. We're going to come back to that, don't worry about it. But pretty much, data is still a variable, but now it's a reference variable, even though int is not uppercase, because it's an array of int, it's going to be an object. So it's a reference variable to an object of class array of int that contains the data 1, 2, and 3. So it's an array with 3 slots inside of it, okay? So why do I do this? Again, to go from a primitive data type, like data equal 42, to something where data is going to be a reference variable referring to an object in memory that contains the data. Okay? So I'm using arrays a little bit ahead of time here just to make my point. So if I try to display, actually, I'm going to show you what it does here. If I try to display data like this, so let me comment this so that it compiles. Let's try to compile. If I try to display data before and after, this is what happens when you give to system.out.println a variable that contains a reference. Okay. Actually, most of the time, system.out.println is a little smarter. It says, oh, this is a reference. Let me see if I can call a method on that object that you are referring so that it would tell me how to display it. But here in this case, there's nothing by default that tells Java how to display an array. So what you see here, this is the value of a reference. If needed, that just proves to us that data is no longer a primitive data type. That's not actually the value 1, 2, 3 or anything like that. This is just pretty much the quote unquote memory address where to find the object that contains 1, 2, and 3, the array of int object. Okay? So if I want to display that in a readable manner, there's a little method here that I can use. Arrays the toString. Okay? And this is just going to transform that array, not transform, but it's going to return to me a value, which is going to be a string that represents what's inside the array. To be able to do that, I'm going to use import arrays, java.arrays, java.util.arrays. Sorry. All right, let's try to compile this. And now if I try to run that, so now it's calling that method. And again, most of the time this is done automatically, but arrays are peculiar. There's a lot of exception with reference data types, okay? So what's happening here is that I call that method, I get a string that represents this is what's in your array, 1, 2, and 3. Okay. All right, so now I have an array. I still want to call my method. Of course, if I try to call it right now, it's going to tell me, whoa, you expect the method here to take a single int value, and you pass to me an array. Okay, so be it. I'm going to pass an array here too. Okay, so this is just a syntax to declare the data type to declare a parameter p of data type array of int, just like we declared a data of data type array of int. Okay, so p is going to be a reference parameter, a parameter that's meant to hold a reference. I'm going to call the method one with data. Data is that reference where to find the object. That reference is going to be copied into P. And then I need a way to say, I want to change not the value of P, but I want to change what's inside the array that P refers to. So again, a little bit of syntax, but don't worry, we're going to look at that syntax in detail again in a future module, okay? I use a square bracket again to say, I want to change the first element in my array. So I want to use P that contains a reference to my array, okay? I use P, I follow the reference, I look at the first element in my array, I change its value. Instead of being 1, it's going to become 99. Well, that should not work, right? Because every method is isolated, blah, 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 blah. Yes, it does. So now I need to reformulate the rule that we have been using until now, okay? Every time you call a method and every time you pass a parameter to that method, you will have, from now on, to be careful about whether the data type of the parameter is a primitive data type, in which case, you pass only the value, a copy of the value. You cannot modify anything that is in the main from the method itself. Or if your parameter is a reference data type, what you pass is actually the reference where to find an object. So it's kind of like giving the key of a car to somebody, right? I give you a picture of the car. You can do whatever you want with the picture. It's not going to change my car. I give you the keys of my car. You can go ahead and wreck it in the campus, right? So that's what we're talking about. When you pass a reference to a method, you enable the code inside the method to access the object being referenced. And so this is what allows me here, p index 0 equal 99, to modify this value here inside the object of data type array of int. Okay? So That's a lot of new stuff, but again, I'm seeding, okay, what's coming up next module or the one after that, okay? So more importantly for us right now, it sets that warning, okay? Reference data types can behave differently. And just to be honest, what if I tried the same experiment with string? That would have made more sense, right? We're talking about string. Why did I bother introducing arrays? Well, try it out. Declare a variable of type string inside the main. Then try to pass a parameter of type string to my method, okay, or my method one, whatever we called it, okay. And inside method one, try to modify the string, using the name, for example, let's say your parameter is s for string, s dot, and then what? What can we do on a string that's going to modify what's inside of it, the characters? Nothing. That's called immutability. The string class is immutable. It cannot be mutated. It cannot be changed. So once you say the string object contains hello, there's nothing you can do to transform, for example, hello into hi, or to change a hello uppercase h to hello lowercase h. A string object, once it has been built, cannot be altered. So under those circumstances, does it matter that when I pass a reference to a string object, the method could potentially, call method and do things on the object? Well, not really, because there's nothing it can do that's going to change the content. So we are back to what's happening with primitive data type, okay? I could not pass a string to a method and have this method modify something inside of the string. So we're going to revisit that topic a lot, okay? We start COP2513 by going in depth into that. As soon as we do arrays, we are going to revisit that same example. We're going to go a little bit more in depth. This is something that is very important in understanding how a programming language works. But don't freak out. Right now, we just did a quick overview to give you a taste. We are going to revisit this stuff. For now, what's left in the module for us to cover is a lot easier than that. It's less conceptual. We are back to catalog, right? We are back to, okay, we have a class string, and this class string is going to allow us to create objects of class string. And then when we have one of those objects, what can we do to it? What can we call? What kind of method can we call on the object? So these are the basic method. They are not the only method. If you check out, if you Google Java doc in one word, Java doc Oracle, that's the name of the company behind Java, and then string, you're going to see that the class string has actually a lot of methods. In the textbook, we start with those 6, and they're kind of enough to get us started with the stuff, okay? So length, kind of easy to guess what it's going to do. Char at, which is going to allow us to look at what's inside the string, character per character, but not change the characters. Concat, concatenation. Concatenation means putting 2 things one after the other. So if I have a string that say hello, a string that say there, what I can do with concatenation is create a third string that says hello there. But I create a third string that says hello there. I didn't take the text there and insert it at the end of hello. I didn't take the text hello and insert it in this string at the beginning before there. Now, I had 2 strings. The only thing I can do to merge them is create a new one. That's, again, the concept of immutability. Once you've created the first string and the second string, you are guaranteed that the text in them cannot be modified. Yeah. Yes, but you have to do it 2 at a time. Okay. So we're going to look at the syntax. The syntax uses also the plus symbol for concatenating string and stuff like that. So you could say hello plus there plus exclamation mark. And yes, that would work, but it does a concatenation 2 at a time. And every intermediary step, it creates a new string. So that should kind of make you think maybe right now that, wow, as soon as we start using objects in Java, it's going nuts. Apparently, there are some objects that are immutable, like string, and every time we do operation on them, we cannot just modify an existing object. We have to create a new object. So it's okay if the object is small, but what if the object is large? Well, that can be a problem, yeah. So there are some optimization in Java, but yes, that's the idea. When you use object, you add a layer of abstraction to your programming, right? You have more expressive tools, but you pay the price. Okay. For example, somebody did a little experiment in an old. It was an old issue of ACM Inroads magazine. They published, how to solve a puzzle called the Tower of Hanoi. Doesn't matter what it is, but it's pretty much a puzzle that you can solve automatically with a piece of code. They implemented the same solution in Java and in C, the programming language that you are going to study in COP2512. Well, regardless of all the optimizations the Java compiler tries to do automatically, there was still, I think it was 100 or 300, between 100 and 300 as a factor of difference in execution speed. So yes, picking the language has an impact on the speed you can reach, that you can affect actually with that language. Okay, so creating all those objects, it costs us, but generally the benefit outweighed the little overhead that it incurs. Two uppercase, two lowercase. Well, it sounds like we're trying to transform strings again, but we're not. I'm going to show you how those work. Trim is a very interesting one. It's there to remove blank spaces. So for example, if I have a string that says space, space, hello, space, 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 the space character 3 times before, 3 times after. If I call trim on that string, it's going to cut the extra spaces at the beginning and at the end. So the resulting string will just say hello. Now, if I have like multiple word, like hello there with multiple space in between, those are not touched. It's just the spaces that exist at the beginning and at the end of the string. We're going to look at how that works again with a little live coding example, okay? The one thing you need to be careful about, all of those methods, we don't call them with string, the name of the class, dot, the name of the method, like we did with math, like we did with character, like we did even with system, okay? Now, we always create a reference variable of type string, create an object of class string, pass the reference variable so that it refers to that object, and then use the reference variable name dot, the name of the method parameters. So exactly what we did with scanner. Scanner s equal new scanner, create the variable s, create a scanner, put the reference where to find the scanner object into variable s, and now we can do s.nextInt, s.next double. So we can call the method on the object using the reference variable. So let's start with probably the easiest one, right? Let's say we have a string that says welcome to Java. So if I want at some point to display or to use in a calculation the length of that string, I just call the method dot length empty parentheses. So it's a method that takes no parameter, hence the empty parentheses, and it's going to return to me an int value, which is actually the number of characters inside that string. Okay, so very easy to use. That's probably the easiest, like I said. The next one is char at. So char at is a method that we use to, I was going to say extract, but we don't extract anything, to get a copy of one single character inside the string. So what is the data type in Java that we use for a one single character? Char. Yeah, I read your mind. So char is the primitive data type that we use in Java to mean one character. So that's going to be what this method returns. How do we use it? Well, let's say that we have a string message. So again, okay, pedantic. I declare a reference variable named message, meant to hold the reference to an object of class string. And then I create here with a literal the object of class string, and I put its reference inside the variable message. And now I can do message.length, and I get the length of that thing. Message does char at and a number. I get what? I get the character located at this index. So from now on, when you think about a string, think about this. And yes, it kind of has to do with arrays, right? That's kind of the way I describe to you an array. An array is a variable that can contain, multiple value. Well, a string is an object in Java that can contain multiple single characters, one after the other, right? When you call dot length, here it's going to tell you there are 15 characters. Now, the way that we refer to those characters, we use indexes. And the only thing that you have to be careful about is the indexing starts at 0. Starting to count at 0 is something that is very common in programming. There are very few programming languages that start counting at 1. COBOL might be one of them. Fortran was maybe one of them. I don't remember. These are languages from the 70s, right? I don't think anybody did that trick again since then. We kind of all got used to every time we count indexes in an array, or every time we count indexes in a string, we start counting at 0. Okay? So if I do message dot char at index 0, that call to the method on the object referred to by the reference variable message is going to return to me a single character. So that is like char. That is going to be that W uppercase. So I have a way to go for a string and display one specific character as a string. Or I could have a loop here, iterate over the entire string, right? And just display one by one on the screen the character of that string. Let's do that real quick. It's not going to be really complicated. It's going to just be a matter of, and I'm going to remove all of this, actually, because we don't need it anymore. It's just going to be a matter of saying, I want a string S. I know. Thank you. I try to act like I know, but I don't really. So that's why I appreciate that you remind me. Okay, string S equal. So now I'm in the wrong window. We're going to get there, don't worry. String S equals something. Okay. And now I'm going to do a loop over it. So I need a counter int. I'm going to call it n equals 0. Okay. And then I'm going to say while n lesser than s, my string, dot length. So I measure the length, okay? And then I'm going to count 0, 1, 2, 3 up to that length, not included. And inside the while loop, I don't put the curly brace because I don't anticipate needing more than one statement in the loop. Inside of the loop, I can do system.out.print, and I'm going to display the character at index n inside the string s. So s.char at index n. And I want to display that character followed by a space. Okay, so I concatenate an empty, not an empty string, a string with just a space in it. And I'm going to keep doing that. And at the end, system.out.println, I'm just going to display, pretty much go to the next line. Okay, let's see if that works. Compiles, run. Yeah, I forgot one thing. So that's not going to work really well. It displays S, 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 S. So what did I forget? Bingo. So I could do what any rational programmer and clean programmer would do, which is, add curly braces here. And then at the end of the loop, n equal n plus 1, or n plus plus, or n plus equal 1. Okay. I could do that. Compile it, run it, and it works. But I could also do n plus plus here, keep the body of my loop to only one statement, so I don't need curly braces. Okay, and this is the beginning of the end. This is how you start writing code and being all proud of yourself, and then progressively you make the code smarter and smarter up to the point that your code outsmarts you. I come not for that, but I come back 6 months after writing a piece of code, and I'm scratching my head for 10 minutes, saying like, okay, I know I'm doing something, but I don't remember why this is working. Okay, and this happens a lot. So it's even worse when you're reading somebody else's code. But anyway, you'll have time to experience that kind of stuff. Going back to the slide, so we're just like experimenting with very easy methods right now. Let's take a look at the next ones on the list. So we have 2 lowercase, 2 uppercase, and trim. So the interesting thing with those methods is they are going to be a great opportunity for me to reinforce again the idea that strings are immutable. And this is an important thing to know when you start manipulating strings. So that means that When I call s equals s dot to lowercase, I apply the method to lowercase to the string referenced by s, welcome. So it's going to turn each letter into its lowercase counterpart. But it's not going to change the letters in there. It's going to return to me a brand new string object, the reference to a brand new string object. And that brand new string object contains a copy of welcome spelled all in lowercase. When you think about it, that's pretty wasteful. Okay? It's like saying, you know, I have this novel, 2,000 pages. Oh, but I forgot a semicolon here. Here, let me do this. I'm going to take my pen, add a semicolon on this line. That's it. It's fixed. And Java says, no, no, no. I'm going to make a copy of the 2,000 pages. And in that copy, I'm going to add the semicolon. Here you are. So when you do that a few times, you start thinking about, well, maybe I should modify multiple things in one shot. Otherwise, I'm going to kill the Amazonian forest in terms of trees, right? So, but that's exactly what's happening in memory here. So to lowercase works like that, to uppercase works like that, and trim works like that as well. So we can do a quick experiment here. We can go, for example, we can use a string s something, why not? And we are going to use, so we could use any of the method. Let's start with trim maybe. So system. I have a new goal for today. Remembering when I switched to GGRAPH. So I'm going to call, system.out.println. This is what my life has become. And I'm going to call, so how am I going to do that? Let me think a minute. I'm going to call system.out.println s. But here, I'm going to do s.trim. Okay? So let me add a few spaces here, a few spaces there. And the goal of trim is to remove the space at the beginning and at the end, right? That's what the docs say. So I call s.trim, and then I display the string referred by s. And it's hard to see, so I'm going to do a little trick here so that it's easier to see. I'm going to put an opening, a square brace here, and then I'm going to put a closing square bracket here. There we go. I didn't get rid of the spaces at all. So that shows you that the string is immutable. What happened here, sorry, what happened here is I call the method string on the object referred to by s. So that's this guy here, that's this guy. And the method trim made an entire copy of everything there. And that copy has no extra space. And it returns the reference to the copy. But what do I do with the reference to that copy? I don't even assign it to any variable or do anything with it. So it's just, you know, lost. It's like me saying here, here's the request, the data you requested. I drop it and you're like, I'm not touching that. It falls on the floor. We didn't use it, right? So when I go back to S still refers to the original object. It has not been modified. Yeah. So now this is why we had that weird pattern, right, in the previous slide. So if I want something to happen, I'm going to write s equal s.stream. So that means that, again, I'm not changing this object. S originally refers to the text something with extra spaces. I call trim on that object. It returns a new string variable that doesn't have extra spaces. And now I say I want S to no longer refer to the old version, but refer instead to the new version. But you do realize that if the string objects are those tables, right, these things still exist in memory. So somewhere in memory, I have the old version of the text, and then I created a new version that has no extra space. And all I'm doing with the variable s is decide, okay, which one do I refer to? This one originally, once it has been modified, I want to refer to the new version. There is a level of indirection with references, okay? Get used to it. Very, very important, okay? We're going to work on that together. Don't worry, you're going to get a lot of practice, but don't overlook it as just a little tedious detail. It's essential in Java, and it's going to be even more essential when you deal with pointers in COP2512. Drawing your attention to that, is probably the one single best thing I can do to help you prepare for programming in the C language. Okay, learning to deal with those indirection, those reference to other things, so that when you come and work with pointers, you're not going to be that surprised. Okay. All right, so we can do it like that, or we could do string s2 equal s.stream, s.trim, sorry, and then I can display. Now I'm getting paranoid. Now I can display s and s2. All right. And you see exactly what happened, right? Like when I do s equal s.trim, I always have a bunch of students that gets a little confused with that. They say, well, did you change s? I changed a variable. Okay, but I didn't change the object. I just made the variable refer to another object. So that's the difficulty. When I do it like that, generally everybody, almost everybody understands. You call trim on s, it returns the address of a new string. So there are two string objects in memory right now. The first one contains still the original stuff that we had. There you go. The second one contains a copy of the original where we remove the extra space. And of course, I can do that with, for example, if I spell something like this, instead of using .trim, I can use to lower. Cannot find symbol to lower, so did I misspell that? Hold on, I have a blank. To lower case. Okay. To lower case. Okay, that works better. By the way, all the string methods, they come included. You don't have to do an import for them. Okay, they are so common that they're included by default. And when I run this, you can see that the original was spelled space, 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 something with uppercase S, uppercase T. The modified version is just using lowercase. Do you see what I mean? Do you see what I mean when I remember to put it on the screen? That helps, huh? So what was hard about this chapter? The fact that I cannot remember to put JGrass on the screen, okay? If that's the only thing that was hard, you guys are doing really well, and I apologize for that, okay? But other than that, two lowercase, two uppercase. Let's try it since we are like pretty much doing all the examples here. Run. There we go, right? So always the same idea. Clone, pretty much clone an object, make a copy of the object, and that cloned version is what has been modified in the process of cloning, okay? All right, so I hope by now you're starting to see some sort of consistency, like some theme going on with those reference data types, okay? And the problem when you first teach reference data type is that I cannot yet give you really hard rules because I'm teaching you what reference data type are like using the string data type, which is a special type of reference data type. It's an immutable one. So we are learning two things at the same time. Oh, hey, this is what happened when you use reference data types. And oh, by the way, this is not going to happen with string because string is immutable. So here's instead what you have to pay attention to. So once you delineate those two levels, okay, it should start making sense. But it's really going to click for most of you when we do arrays in one or two modules, and we start looking at another string reference data type, okay, that behaves a little bit more like you would expect reference data types to behave. What about conversion of strings? So we use the opposite of that, okay? But we have also methods that allow us to read a number from a string. So parse int. So these do not come from the class string, by the way. They come from, for example, the class integer. Do you want to read the text of a string and extract an int value from it? Use the class integer. Do you want to read the text of a string and extract from it a double value? Use the class double. So we just discovered that every primitive data type has a counterpart, which is a class that contains all the methods related to that primitive data type. So all the methods related to int are inside a class called integer. All the methods related to double are inside a class double. So how does that work? Pretty easily, actually. Like, let's say that I have like 42 here in my string s. As you can see, I have 42 in my string s. I don't get tired of it, apparently. Yeah? All right, I have 42 here, and I'm going to call system.out.println. And I'm going to call, so I'm going to just do it once. I'm going to call integer dot parse int of s. So that literally means takes us to the text s, the string s, parse it. Parsing is jargon for actually analyze the character and recognize the pattern of an int value inside of the text. So for example, 4 and 2 together, that means 42. And then return that to me as an int, and I'm going to display that. Let's see if that compiles. Let's run it. So it displays the value 42. So displaying the value 42 is kind of like a bad example because I had a string to start off with. So I could have displayed that by myself, right? So I can instead do something like int value equal integer.parseInt. So this time the variable value is of type int, and I can then display the content of the variable value. So it's a little less, how to say it, a little less obvious that we are not just keeping the string as it is. Yes. What would happen if there were characters? Yes. Yes. Welcome to my lair. Okay, so this is where it gets funny. So for example, the value is 42. Okay. So there are a bunch of exceptions we need to look at. So the value equal 42, that doesn't make the method happy. I was going to say the compiler, but this is not a compiler error. This is actually the method telling when I try to run, when I try to decipher what's in the text referred to by S, okay, I'm looking for like numbers. So I should start with a digit, and maybe another digit, and then I'm going to figure out, what they mean. But instead, I find stuff like a T, a H, a E. I don't know what you want from me. So this is a way to say, I don't know what you want from me. It raises an exception. The name of the exception is number format exception. So that's kind of a clear name once you know what's going on. Okay, it's telling you this is not the format of an int value. The same will happen, by the way, if you try to do, I think the same would happen if you try to do a double. Let's try. Yeah. So it's telling you, again, number format exception. You told me you wanted an int. I look and I say 4, 2. So yeah, I can turn that into an int. Dot. Okay, now that's it. That's not an int, that's a float. So if I wanted to actually process that, I would say double here and double there. And again, double here. And that would give me a chance actually to pretty much have the right method used on the right type of text to decipher the text appropriately. But if you use a parse int and there is no int or there's an int plus garbage around it, it fails. If you use parse double and there is like something that has garbage around the value, it's going to fail as well. Okay? That's not my fault. No, just kidding. But yeah, the screen tends to turn on and off. I haven't figured out exactly what triggers it, but I'm upsetting the HDMI connection at some point, I guess. So we talked about converting from strings to numbers. There is another thing that we can do with strings. So I'm going to remind you of it on the slide, is we can convert from numbers to string. We've seen that already, okay? So how could we do this? One easy way, string s equals number. So I'm going to assume number is a double or an int or something like that, right? So number, variable number, plus double quote, double quote. That's the plus that we talked about sooner, that's concatenation, okay? So when I see plus, the first question I need to ask myself is it the addition? Is it the addition between ints? Is it the addition between floats? Is it the concatenation of strings? So you know that you are going to talk about concatenation of strings when at least one of the two operands of the plus operator is itself a string. So by adding an empty string, which is completely stupid, right? If I want to concatenate an empty string at the end of hello, what is the result of that? Hello. If I concatenate it at the beginning, it's still hello. But it allows me to make one of the two operand of type string, which causes a plus to work in terms of concatenation, which causes the first operand here to be automatically, implicitly converted to a string. So there you go. I got my number to string conversion done automatically for me. So number that contains 42, for example, is going to be converted to double quote, 42 double quote, the string that represents 42. And that's going to be concatenated with nothing. That's going to give me the string that contains 4 followed by 2. And that's exactly what I wanted. The other way to do that we actually used before, we used it when we talked about number systems, is to say string s equal integer.toString number 10. So integer.toString is a method that converts an integer value to a string representation of that value. And if you remember, we had a second parameter here that allowed us to say, well, what is a base? What kind of base do you want me to use when I read this number? So here I'm assuming, we want to use decimal base. So here we go, 10. So a few slides ago, we had a method concat. The method concat and the plus, they're exactly the same thing. They do concatenation. Yeah. Oh, just s equal numbers? Okay, let's take a look. So what you have here is you could have implicit typecasting, okay? But I'm not sure you are going to actually get your implicit typecasting for free in Java. That's why we're going to double check. So I have a string here. So string s equal, let's go with just an int, okay? Or let's start with the easiest stuff. String s equal 42. Now it's not accepting it. So it's not doing implicit typecasting. I wasn't sure of that actually, but it's not doing implicit typecasting for free between int and strings. That's why you have to force it. You have to force the hand of the Java runtime system here. If I write this, then it's happy with it. Okay, but I had to force the hand. So this is just a piece of code that literally you could say it means nothing. Okay, but it makes sense only when you understand how Java is working with those data type and how it is, not doing implicit typecasting, but will do explicit typecasting in this particular scenario. Okay. All right. Good question. So going back to this, concat and plus, they are really the same thing. Okay. So when you write string message equal welcome plus 2 plus Java, okay, what happened is that you're going to get those two concatenated together. So that's going to give me a new string to Java. Then welcome concatenated to 2 Java gives me another string, welcome to Java. And that's the result of that expression. But I could use the concat syntax. So I could say, do I use it somewhere here? No, apparently not. But I could say welcome dot concat to, and all of that dot concat Java, whatever you prefer. Okay, the two notation are available and perfectly fine. And then we have situation here where you use a plus operator, okay, with an int, with a char. You could use it with a double, with a boolean, even that works. Yeah, that works. Pretty much every time you do a plus between a string and something else, that something else is going to be converted for free to a string. And then you're going to concatenate the two. And that's completely implicit. All right. This one is a problem. This is going to be the source of bugs for many of you. So I'm just giving you a heads up. I'm not sure that giving you a heads up is going to spare you having to deal with that bug, okay? Because every semester I see it. But this is danger, red zone territory. So the topic for this slide is, how do I compare a string? I have a string that says a first name, like John. I have another string that says the same first name, John. How do I say if the first name that I got here is equal to the second name I got there, then do something else, do something else? Well, the first reflex would be to say, I know how to test equality. It's equal, equal. And if I want to test if the two strings are different, it's exclamation mark equal. So what we have here is what common sense would tell us. Nobody breathe too hard. Okay, maybe we should all breathe hard. I don't know. Okay, so back to this slide here. So that's what common sense tells us. We've been comparing values before. We've been comparing primitive data types value. So this is another one of those. Watch out, we're starting to use reference data types. They're weird, okay? So I'm going to give you a temporary rule of thumb right now. Never compare two strings using equal or exclamation mark equal. If you remember just that, okay, you just saved yourself probably a few hours of debugging over the entire semester, okay? Never compare them the same way that you compare primitive data types. When you have a reference data type, always look for methods that allow you to call the method on one of the object, pass as parameters the other object with which you want to compare, and let the method figure out if they are the same, if they contain the same information or not, okay? All right, so what are the method in the case of strings? Equals. So a string dot equals, and I pass the reference to another string, returns true if they contain the same text. Dot equals ignore case. Sometimes I don't care if it's John uppercase J or John lowercase j. So that's going to return true if the two string contains the same text, when I ignore differences between uppercase, lowercase. And then compare to, that one is a little bit more involved. It returns actually an int value that's going to allow me not only to check if the strings are the same, but check also, which one would come first in a dictionary. What is the alphabetical order between them, okay? And then we have like extra bonus method here. Start with is going to allow me to specify a string as prefix, and it's going to tell me if that string s.start with has actually those character at the beginning or those character at the end. So those one, yeah, kind of just like partial comparison, okay? But these equals ignore case compared to ignore case. These are the important one. These are the one you want to use actually when you compare string instead of equal. So here's a little example. Declare and initialize a scanner. System.add.println enters the name of a city. String city1 equal input.nextLine. So remember, nextLine reads everything the user type up to the moment they type enter. Then enters the name of a second city. String city2 equal input.nextLine. The cities in alphabetical order are, and then I'm going to say if city1.compare to city2 lesser than 0, system.add.println city1 then city2. Otherwise, system.add.println city2 then city1. So what's going on with this compare to? So dot equals returns true or false. Everybody understand dot equals. S1 dot equals S2. Well, it's true if S1 contains the same text as S2. So that one is okay. This one here, there's a convention. When you call a string dot compared to another string, if it returns something that is lesser than 0, no matter the value, that means that this one comes first in the alphabetical order before that one. Easy way to remember it is you are going to compare the return value of compare to 0. If you use lesser than, consider this to be an arrow pointing to this guy. If you test greater than 0, any positive value will mean that city2 is the one that comes first. And if it's exactly 0, if the return value of this thing is exactly 0, then that means the two strings are completely identical. Okay? So we can do the same job than equals with compare to. We just have to compare the string and test if the return value is 0. So a little bit more involved, a little bit more awkward, but hey, if we have to do that, it's not unfuzzible. Okay? Before to jump to the next topic, which is substring, we are going to look at something real quick here back in Java. And I know. There we go. This time I remembered. Wow, it took me only 1 hour to warm up. Awesome. All right. So going back to live coding, we need just the main. We are going to need two strings. So let's say something, and I'm going to call that S1, and then I'm going to say string S2 equals something. Okay. And then I'm going to do just an if statement. And I'm going to say if S1, so dot equals S2, system out println, they are the same. Okay, compile this, run it. Hooray, they are the same. And of course, if I modify them, even just putting a lowercase to uppercase, that's going to give me something different. This time it doesn't display they are the same. Okay, so it works as expected. So this is the proper way to compare to string. This is the other proper way to compare to string. Use compare to. And the rule is that if compare to returns 0, then you're good. They are the same string. Okay? If it doesn't return 0, like lesser than 0, or something like that, then it's going to tell you the first one comes first, the second one comes first. Okay, whichever the lesser than or greater than is pretty much pointing to. So we have two ways to compare the strings. Okay, and then what about that way that is a forbidden way? The one that I told you don't use it. S1 equal S2. So if I try to do that, run it, it's not displaying anything. So that's a little odd, right? Actually, that's really, really odd. There's something going on weird here. Hold on, let me check. Yeah, it's still compiling the new version of the code. Let me put an else statement here. Okay, so that's more what I was expecting. So I don't know what happened here. Probably I didn't save the file or something like that, so it didn't take into account the latest version of the code. So beside like little IDE using glitches, user errors, what happens here is actually interesting because it's saying we use the wrong way of comparing strings, but it still works. So sometimes the wrong way of comparing string will work. Sometimes, most of the time, it will not work. Okay? So the problem with the wrong way of comparing string is it's not a clear cut. It's not like if you do it, compiler error or crashes at runtime or something like that. That would be nice. No, the problem with using equal is that sometimes it works, sometimes it doesn't work. So let's try to understand what's happening here. String S1 equals something. Yeah? Oh yeah, you're right. Well, maybe that's why they're still doing what I want, but I force them, and they are not the same. So let's see if that's still doing that. If that's not doing that, I know what's going on, but okay. Yes, there we go. Thank you. Where's Waldo? Awesome. All right, so now we're back on track. So what's happening here is, so rewind. Now I'm not going to lie. The strings are the same, right? I'm still using the wrong version of comparing them, but I still get the right result. So here's what happened with equal. Very important. Equal or different, okay? Equal or different, what they do, the reason they worked on int and double and float and boolean, what they do is they take a value, compare it to another value. So what happens when I say S1 equal S2? S1 is a variable. S2 is a variable. So let me look at the value inside of S1. What do I find? The reference to something. So something else. What about S2? What is inside the variable S2? A reference to another string, right? So what this is telling me is the reference to an object of class string inside S1 and the reference to an object of class string inside S2, they are the same. So both variable S1 and variable S2, they refer to the same object in memory of class string, inside of which I wrote something. Okay? But it looks like I have two different objects here. Well, that's a trick inside a trick inside a trick inside a trick. What Java is doing here is, oh, you have a string literal something. Let me help you. I'm going to create an object of class string that contains something. Oh, you have another literal that's spelled exactly the same. You know what? I'm going to create an object, but wait. I'm not going to create a new object. I'm going to be smart. I'm going to make things run faster in Java. So since the two literals were the same, I'm going to reuse the object I created the first time and put its reference inside of S2. And that happens only when you use string literal to create things. For example, if I did here new string, I want to create a string that is a copy of blah, 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 the string that contains something. If I do this, now it's not working anymore because S1 refers to an object that contains something. S2 refers to another object that contains something. The fact that they have the same text inside of them, that's not the business of equal equal. Equal and different, exclamation mark equal, they are only looking at the reference value. Are you both talking about the same object in memory, the same one string object? Yes or no? And I don't care about what they contain. So that's why we use those methods, because most of the time, that's not what we're interested in. We're not trying to detect if Java has somewhat optimized things, behind the scene and manage, to save a little bit of memory space by storing two objects that contain the same stuff under the same memory object. We don't care about that. But what we care about most of the time is the quality of the contents inside the objects. And that's the hardest part about strings. Well, there have been quite a few, okay? Yeah?
So when you put new string, you force it to have a different reference?
Yeah, because the new keyword means I want a new object. I want to create an object. That object will contain, it will be of class string, so new string, parentheses, the value that object will contain is, double quote, something, double quote. So I force the hand of the Java language. I say, I want my new object. So now S1 was referring to this object, S2 was referring to that object. Okay, the equal tells me they are different objects, but they have the same text. Don't care. Equal looks at compares the references. Dot equals compares the content. And that's going to be true for every reference data type we're going to explore starting now and all through COP2512. Okay? Last thing that I'm going to introduce real quick, but compared to that stuff, it's a lot less sneaky. Okay? Two methods. So substring and then the one in the next slide. They are kind of explicit. A substring is going to look inside a string and return to you a new string object that's just like a part of the original string. So for example, if I say I have a string message that contains welcome to Java, and I call message.substring 0 to 11, it's going to look inside the string referred to by message from index 0 to 11 and return a new string that's going to be a copy of everything between index 0 to 11. The only thing that's a source of bug, 11 is not included. So message.substring 0 to 11 is going to return a copy of all those characters up to and including index 10. So if I say 11, it's up to and including index 10. That's the only trick there is to know about substring, okay? And then there are two versions of the method, one with two parameters that works like I explained, and one that takes only one parameter. So if I say message.substring of 11, it's going to return to me a substring starting at index 11. So the start index is always included and going up to the end of the string. So that's going to be the substring that says Java. Yeah? Yeah, we don't. So no, Python is a lot better at accepting negative numbers for index of arrays and stuff like that. Java is still old-fashioned in that stuff. So you use actually valid index. If not, you're going to get a warning. Okay? All right. So we have substring. I'm going to let you take a look at finding a character in the string between now and next time. I'll upload actually in the slide a few more examples. And there's going to be an exercise, consider it a practice exercise at the end of the slide. So it's like a few slides down the road, but a lot of this is repeat. So in the extra example, there are two exercises actually. The second exercise is called the Parson puzzle. Try to solve it, okay? And let me know if that helps or not. That should be, if you can actually tackle that level of code here, you are going to have less problem with actually the CGQ, okay? So the CGQ is going to reinforce this. I don't have the deadline set in Canvas. I'm going to set them in between after my morning and afternoon class, but it's going to be released for this week as usual. Make sure that there's stuff about equal, the reference comparison, and there's a code example here. Make sure that you work on them before the CGQ. And next lecture, we'll start with that and we'll take a look at it together. Okay? All right, thank you.